All right, so here's the problem we're working with here. If you have 2.50 grams of nitrogen oxide, and this is how many grams of oxygen we needed to completely react with that amount, and we just did that, balance that formula, or balance that equation a moment ago. Okay, so this is the equation we're talking about right here. All right, so we've already done that. I don't need to do it again, but we're going to need this balanced equation to be able to solve this problem, because we're going from one species, nitrogen oxide, to another species, that of oxygen. And anytime you go from one species to another, you need a balanced equation. And the balanced equation is where you get the molar ratio from to make that conversion from one species to another. Okay? Anytime you're going from one species to another, you need a balanced equation. And it's from the coefficients in the balanced equation you get the molar ratio that allows you to convert from one species to another. All right? So what we're doing here in this problem, let's do a sort of a map of our solution. Okay? We're going to go from the mass. Anytime you're going from one species to another, and that's what we're doing here. We're going from one species to another. We've got to have a balanced chemical equation. Anytime you're going from one species to another, you've got to have a balanced chemical equation. It's from that balanced equation, and particularly from the coefficients in that balanced equation, that you get the molar ratio that allows you to make that conversion. So we're going from the mass of nitrogen oxide to a mass. Grams measures mass. So we're going from mass of nitrogen oxide to a mass of oxygen here. Okay? So we're trying to get from here to here. Okay? Trying to get from here to here. Alright? You can't get from here to there. Not directly anyway. Okay? You ever heard anybody say you can't get there from here? You ever heard that joke? You can't get there from here? This is kind of the same thing. You can't get here. Get here. You can't get there from here. All right? You can't get there from here. We've got to go around. We can't go straight there. We've got to go through a place called Moleville. Got to go through Moleville. All right? All right. So here's what we have to do. We have to first convert excuse me, this mass of nitrogen oxide, excuse me, 2.50 grams of nitrogen oxide is the mass. Man, I want to choke to death. I might need to. We got to go from that to the moles of nitrogen oxide. So NO is the formula for nitrogen oxide in that balanced equation. And we do that by using molar mass. We're going to calculate the molar mass to get from here to here.
So anytime going from one species to another, you use molar mass?
No, this is not going from one species to another. This is the same species. Here we're converting from mass to moles. That's what we need molar mass for. Okay? But now, once we're at moles of NO, we can go directly from moles of NO to moles of oxygen. Yeah, it does. I said we got to go through Moleville. All right. So, and when we go from moles of one species to moles of some other species, so NO is one species and our oxygen is the other species. To go from one species to another, we've got to have a balanced chemical equation. And we use the coefficients in front of those species to write a molar ratio. So we're going to go through this molar ratio to get from moles of one species to moles of another. All right? And then to get from moles of one species to mass, we still have to have a molar mass. So we're going to go from here to here using molar mass again. So from oxygen to from moles of oxygen to the mass of oxygen, you go through molar mass. Okay? All right. So there's Moleville. We just annexed that into Moleville. Okay. This is the city limits, and that's the city limits. This is downtown Moleville here. Downtown Moleville. Okay. All right. So let's do this math. Okay. Now this is a multi-step problem using the skills we learned in the last 10 days to make these conversions. So the first thing we got to do is go from mass of nitrogen oxide to moles of nitrogen oxide, and for that we need the molar mass of nitrogen oxide. So we're going to add up all the atomic masses of all the atoms in the formula, write that in units of grams, and set that equal to 1 mole of the same species. That's our definition from last week. So if you get out your test references, Brandon, and practice with them, you will be able to find the atomic mass of nitrogen to be 14.0067, and oxygen is 15.9994, and we're just going to add those up. That's all we have is nitrogen and oxygen. Okay? Yeah, we're going to add those together. It's the sum of all the atomic masses of all the atoms in the formula. And the atoms in the formula are 1 nitrogen and 1 oxygen. Okay, then we get out our trusty calculator here. We add those together. Looks like I've already added them together from the last class. How about that? 30.0061. And the definition I gave you a moment ago it's the sum of all the atomic masses of all the atoms in the formula written in units of grams, and setting that equal to 1 mole of that species. And the species here is NO, nitrogen oxide. So there's our molar ratio, or actually our molar mass equality statement. Yes? Yeah, we only have to round off. We're only required to round off. I think what you're talking about is rounding off, using the arrow to move decimal places.
I guess so.
You only are required to round off when you have to round off a digit in the ones place of a number. Well, we don't have to do that here. So there's no requirement that you do scientific notation here. Okay. Now for a lot, what?
It wasn't scientific. It was something to do with when it's like our blank space, I think that's with the arrow going down. I think that's what you're talking about.
Oh, okay. Yeah, all right. So maybe what you're talking about is when we're adding and subtracting, Carolyn, when we're adding and subtracting, if there are empty slots on the right, you have to round off the number that results. And now I have taught my students to put an arrow just so you won't put a 0 there. If you put a 0 there, you're misleading people about the precision of that number, and we don't want to do that. You put an arrow there just as a placeholder instead of putting a 0, because if you put a 0, you're saying this number is more significant. I mean, more precise than it actually is. Okay. Right. Okay. All right. So we've used a lot of arrows in here. I'm trying to get all that straight for you. Okay. Now then, we're going to start with our starting amount up here, 2.50 grams of nitrogen oxide. Okay, now those are two nonmetals. So when you put two nonmetals together, if you need more than one of those, you have to use those prefixes. Di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? But since there are no prefixes here for two nonmetals, then I just have one of each. Okay, so we're going to put that over 1, and we're going to use this equality statement right here to build a conversion unit right here to go from the mass to moles. All right. Say what now?
Put the 30 on the bottom.
Yep, the 30.061 goes on the bottom because we want this side of the equality statement to be here. We want this side of the equality statement to be down here because it matches the units and species that we still have left. Okay? And the other side of the equality statement goes on the top. Okay? And that allows us then to cancel units and species and leave ourselves with what we're looking for, at least at this stage. So grams go away, NO goes away, and we're successfully at moles. Okay, once we did the math anyway, we're at the outskirts of Moleville here. Okay? All right, so we do the math, 2.50 divided by that number. All right. And I get 0.0833 and then we want to round off. How many digits do we need? 3. So where do I start underlining this number?
0.08.
Leading zeros are never significant.
Alright, well, 8.
So this is our first significant digit. Second, third, we need to underline from here over. Okay? Now I haven't put my units down here. This is moles of NO. And we need to put an arrow, not an equal sign because these two numbers are not equal. 0.0833 moles of NO. Okay? Alright, so that's not the end of our problem because we're only right here and we've got to get all the way over here.
I thought that's 4 numbers, eh?
3 digits here, 6 here. I need 3 digits in the final answer.
So that's both of them, so 900 zeros.
The leading zeros are not significant.
Okay, hold on.
You have rules for significant zeros, yes.
Okay, explain that again. Like,
Which part?
when you first got your answer, the long number, 0.08, whatever. How do you determine which one is
I thought the zero at the decimal.
In order for this zero to be significant, it has to follow a decimal place and a non-zero digit.
Oh,
Okay, and since it only has one of those, it's not significant. So leading zeros are not significant even when they follow a decimal place.